today we're going to talk about why using an FMEA alone is not sufficient for risk analysis. Now, I know our industry uses FMEAs almost exclusively for the purpose of risk analysis. So this might come as a surprise and maybe a concern to a lot of you to hear me say that FMEA alone is not sufficient. So we'll talk a lot more about why that is the problem, but most importantly, we'll share a very practical technique, very practical tip that I have used in my practice to actually connect your FMEA to other aspects of risk analysis or other techniques you might be using for a more thorough and complete risk analysis as required by ISO 14971. So today, as I mentioned before, we're going to talk about why FMEA alone is not sufficient for risk analysis, but more importantly, what can we do about it? So this is not going to be just a theoretical conversation, but what we can do about that. And it is not to say that the FMEA is not useful. FMEA is useful, but it is not sufficient. I think that's a key message I want us to learn today. So let's keep the big picture in mind. FMEA is just one tool in your toolbox for risk analysis. Now imagine you call a handyman to do some work in your house and they show up with only one tool, maybe a hammer. Right? I heard somebody say that when the only tool you have is a hammer, every problem looks like a nail. Now there is some truth to that because we cannot solve complicated problems with just one tool. That is why we should look at FMEA as only one of the tools for risk analysis. So what is risk analysis? Well, according to ISO 14971, it is a systematic use of available information to identify hazards and to estimate the risk. So it has two components: identification of the hazards and estimation of risk. Nowhere in this definition of risk analysis does it say that you have to do an FMEA. Okay? So risk is all about identification of hazards and the estimation of the risk associated with those hazards. So let's take a step back and see how risk identification happens. It happens in the context of the intended use, and that's the first thing we need to do. Figure out what the intended use is. Now, intended use has two parts: the normal use and the abnormal use, right? We will focus on the abnormal use right now because it has use error and misuse. Together, they combine to form what we call foreseeable misuse. And then we have characteristics related to safety, which concern the safety aspects of our device. All these elements are required for us to now look at what potential hazards might become active as a sequence of events, and that may lead to hazardous situation and harm. So this is how risk identification occurs in practice. What about risk estimation? So we know that hazards and exposure to hazards is necessary for harm to occur. So how does that happen? Well, we know that a medical device, both in its fault mode or in normal mode, can trigger a sequence of events. And that sequence of events leads to a hazardous situation. And it is that hazardous situation where you have exposure to a hazard. So P1 that we talk about in terms of probability, it is not the probability of a failure mode. It is the probability of exposure to hazard or a hazardous situation occurring. Now, what happens when the hazardous situation occurs? Well, there's another probability of occurrence of harm, which is P2, and severity of harm, and we combine these elements to estimate the risk of harm as a combination of severity and probability. Nowhere in this sort of schematic we are talking about exclusively failure modes. Well, they are part of the P1, but not all of it. And that's the most important point to take away from this slide, is that probability of a failure mode from a given cause producing a given effect is not the same as P1. P1 is different. And that is the most important reason to understand that FMEA alone is not sufficient. So let's briefly look at the requirements, right? What are the requirements? In clause 5.1, a risk analysis process is required. The manufacturer shall perform risk analysis, which we have learned to be composed of two parts: identification and estimation, right? So the manufacturer shall perform risk analysis for the particular medical device as described in subclauses 5.2 to 5.5. The implementation of the planned risk analysis activities and the result of risk analysis shall be recorded in the risk management file. That is the requirement. Now there is some guidance in ISO TR 24971 in Annex B. And the title of that annex is Techniques that Support Risk Analysis. Techniques, it's a plural. It's not just one technique. And the annex describes that some techniques start with the possible harm and analyze a variety of events that can cause that harm. We look at an example of that. Other techniques start with an initiating event and analyze the subsequent sequence or combination of events that could lead to harm. Different tools for different purposes, and we need to use all of them. These techniques are complementary, and it can be necessary to use more than one of them in order to support a thorough and complete risk analysis, which is what we are supposed to do. So FMEA is not the only technique that should be used or is sufficient for risk analysis in the context of 14971. Not to say that FMEA is not useful. It is very useful for a certain purpose, but it is not the Swiss Army knife of risk analysis. We have to use other techniques. So now we will go into a little bit more detail about why there is a problem when we use only an FMEA for the purpose of risk analysis. I'll share with you a top-down approach, a bottom-up approach of articulating the sequence of events and understanding how hazards relate to harms. And I'll also describe to you a case study method to very easily link your FMEA with the rest of risk analysis. That's what we're going to cover in the rest of the presentation.